Okay, in this exercise, we're told that we are going to pull on this arm with two forces represented by vectors A and B, vector A, vector B, and they need to produce a net outward force of 5.6 N. This is the N is for newtons. We haven't gotten into that yet, but we will. So it needs to produce a 5.6 Newton force outwards on the arm. It also says that A and B have equal magnitudes, so they're both however 5-6 newtons or whatever they are. But actually, they didn't have to tell us that. That's a given in the setup of the problem. And actually, this is because they're both point at the same angle. It might be intuitive, but we'll actually run through and show it mathematically too. But because these are at the same angle and they have to produce a net force which is straight outwards, which it says in there, it's an outward traction force, then they actually have to be the same magnitude. If they're pulled at the same angle but with different forces, like if A is greater than B, then it's actually going to have a slightly upwards net force, maybe up like this or something like that. So but we'll show that. We'll actually show it right now as we go through the solution. So it's pretty similar to the sailboat class exercise there. We have these two vectors and we know what the resultant should be. So I'll do some problem solving with this. We know that the resultant vector, if I write this out, actually I'll put that on the bottom. Let me write out what vector A and vector B are in kind of this vector notation. So I'll use reference angles here. So AX, this 32 degrees, AX is going to be A cosine 32, and where A is the magnitude of vector A. So writing out vector A like this, we have vector A is equal to the x component will be the magnitude of A times the cosine of 32. And the y component will be the magnitude of A times the sine of 32. Okay? And vector B, noting this is in the fourth quadrant, the x will be positive, so the x component is going to be the magnitude of B times the cosine of 32. Using a reference angle there, I could have also done whatever that is, 360 minus 32. And the y component, noting, again, fourth quadrant, this is going to have to be adjusted for the fourth quadrant, so it's going to be negative B, negative magnitude of B times the sine of 32. So these would be my components. I have numbers in here, but magnitudes times angles. We don't know the magnitudes, right? So I'm just going to kind of leave them in there as variables. And when I add them together, I must get my resultant net traction force of 5.6 newtons out. I'm going to give these in newtons. So when I add them together, A plus B gives me my resultant. R is going to be equal to, in the x direction, it was supposed to be 5.6. And in the y direction, it should be 0, right? And so from this, you can see, we have these two equations here, this one and this one, right? So two equations, two unknowns, it is solvable. The equations we have are, one is in the x direction, one is in the y direction. The unknowns are the magnitude of A and the magnitude of B, right? It's not that, careful here, I mean, this is AX and this is AY. It's not that we don't know AX and AY, it's really we just don't know the magnitude of A, because we do know the angle, right? So, if we knew the magnitude, we would also know AX and AY because we know the angle, right? So it's not the components per se that we're missing, but the magnitudes we're missing. So really important here, I see this mistake often, thinking that this is AX cosine 32 or something like that. Sometimes I'll see students even throw a subscript on there and say, oh, this is AX cosine 32. That's not right. That's not correct. That's going to throw you for a loop later on. A times the cosine of 32 is AX. A times the sine of 32 is AY. It's not AY sine 32, anything like that. That would be AY sine 32 would actually be A sine 32, which is AY, and then you'd have another sine 32, so sine 32. So you're going to be off by, a factor of sine 32. So it's not, it's not AY sine 32, it's just A sine 32, the magnitude. Let me start out here with this equation, kind of in the y direction, where A sine 32 plus negative B sine 32 equals 0. So we have here A sine 32 plus A negative B sine 32 equals 0. So, I can just do a little bit of algebra here, and I get A sine 32 is equal to B sine 32, which, if you think about this in terms of forces, this is, A sine 32 is my y component of this force. That's a AY. And then the B sine 32 was BY. And if there's, not going to be a net upwards force or downwards force, if these are supposed to add up to 0, then they need to be equal and opposite, right? Equal magnitude, opposite direction. So kind of makes sense there. Showing it mathematically. We have A sine 32 has to equal B sine 32. Well, clearly the sine of 32 is the same as the sine of 32, right? So if I divide both sides by the sine of 32, I just get A equals B, right? A equals B. And this is not, notice this is not a vector. I didn't put like vector A equals vector B. That's not true, right? I wasn't dealing with vectors. I was dealing with just the magnitude. So the magnitude of A is equal to the magnitude of B. This, of course, was given to us. As it was said to right here, A and B have equal magnitudes. But they didn't need to give us that, really. I mean, it was sort of showed up in our equation anyway. But, as we're getting started, I guess it can't hurt to give extra. So the magnitude of A equals the magnitude of B. So now we can find out what that magnitude is by using our other equation here in the kind of the x direction, if you will. So we'll have A cosine 32, which is AX, plus B cosine 32, which is BX, equals 5.6. So coming through here, we have A cosine 32 plus B cosine 32 is equal to 5.6. It might look like there's two unknowns, but not really, because the magnitude of A is equal to the magnitude of B, so we can just call them both the same thing for all intents and purposes. So I'll get rid of that B and call it an A, because the magnitude is the same, right? So then this gives us 2A cosine 32 is equal to 5.6. And so then we get here A is equal to 5.6 divided by 2 cosine 32. Just a little note here. I just see it happen a lot. When you're plugging this in your calculator, make sure you divide by parentheses 2 times the cosine of 32. Otherwise, if you just type in 5.6 divided by 2 times cosine 32, that will just do 5.6. Then you divide by 2, then you multiply by cosine 32, which is not right. So use those parentheses. See that happen. Okay, so we get here the magnitude of A is equal to 3.3 newtons, which then, of course, the magnitude of B is also 3.3 newtons. Right, so you need to pull on both of those at 3.3 newtons. And it's worthwhile to note here that two pulls at 3.3 newtons would add up to 6.6, right? But this only adds up to 5.6 newtons. It's because it's not, you can't just add the magnitudes. Part of that part of it was being canceled out. The y component of vector A was being canceled by the y component of vector B. So, without the angles, you don't really know exactly how much is canceled out. So you would need to pull them both at 3.3 newtons equally at equal angles in order to produce a net outward force of 5.6 newtons.